Hello and welcome back to System Design series. In this series, we will be learning all the important concepts of high-level system design. Today, our topic is consistent hashing. Hashing is an important topic in any software system. In a distributed system, request distribution, data distribution, for all such activities, we need hashing. Today, we will learn what is simple hashing, what are the problems with simple hashing, why we need to know consistent hashing, what are the benefits of consistent hashing over simple hashing, and some additional information on consistent hashing. To understand simple hashing, let's assume that we have 4 servers where we want to distribute the keys. In order to store the keys into 4 different servers, we have to distribute it uniformly. One option is we can calculate the hash of the key and we can perform modulus operation using the number of servers. This will give us the destination server ID of the key. This technique is known as hashing. For simplicity, let's assume that this hash function is very simple one in our case, where the key will be multiplied with 1. I have taken this for simplicity so that we can easily understand how simple hashing works. Let's assume the hashing function is performing only this. That means whatever keys we will be giving in this function, it will give us the value as key. So our hash function is very simple. It is not performing any other computation on top of the key to calculate hash. In real life, it is not the case, but for our understanding, I have made it a simple function where we can pass the key and we will get the key as output. So that means if we are passing 5 here, it will be multiplied with 1 and we will get the value 5 as the hash value of the key. So this one is the key and this one is the hash value of the key. Remember, in real life, this function is not so easy like only multiplied by 1. In real life, your 5 can have a 120 character long hash value as well. Hope you have realized how hash function works. It takes key as its input and it evaluates some mathematical expression or the function in order to evaluate the hash value of the key. For our example, let's say we have keys from 0 to 15. Total 16 keys we have. What we have to distribute among 4 servers. Let's assume these are the 4 servers where we have to distribute 16 keys uniformly. So this is server 0, server 1, server 2 and server 3. Now based on our example hash function, the 0 modulus 4 will be 0. That means the key 0 will be in server 1. Similarly, 1 modulus 4 is nothing but 1. So key 1 will be on server 1. Similarly, 2 will be on server 2, 3 will be on server 3, 4 will be again on server 0, 5 will be on server 1, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. This will be the distribution of all 16 keys among 4 different servers if we use this hash function. I think so far you are with me. You have realized how using modulus operation we can identify the server ID for a specific key. Till now, the distribution of keys are very simple and uniform. However, in distributed system, we know crashing the server is a very common phenomenon. We cannot rely on a specific server and we cannot assume this server will be up and running forever. Let's assume the server 2 gets down. In this case, if we want to keep all the 16 keys among these 3 servers, we have to perform key redistribution. Why and when we need redistribution of the keys? As and when we are adding a new server into the system or one existing server is down in such two circumstances when we have to perform redistribution of the keys. Hope you have realized when to perform redistribution of keys. Now let's perform the redistribution of the keys and see what are the difficulties we face. Let's assume now we have only 3 servers instead of 4. So it will be S0, this will be S1 and this will be S2, let's assume. Now the redistributed keys will be something like this. Let's count the keys which are moved from one server to other. If I get the relocated keys for server 0, these keys were not there earlier. For server 1, these 3 keys were not there earlier. For server 3, these 3 keys were not there earlier. So altogether, we are redistributing 11 among 16 keys, which is nearly 70% of the keys. In other words, if we use simple hashing technique to distribute all 16 keys among 4 different servers, in case any one server goes down, we have to perform redistribution of the keys. And during redistribution, 70% of the keys will relocate from one server to the other. And this relocation is a costly operation. Hence, we want to have minimum redistribution of keys even if one or more servers are going down in a distributed system. And that is the very reason why consistent hashing has been introduced over simple hashing. So high number of redistribution of keys are the problems in simple hashing. Hope you have realized how simple hashing works and what is the problem in simple hashing technique. Now let's concentrate on consistent hashing. Let's understand how consistent hashing is helping us in order to reduce the redistribution of keys even if one or more servers are going down in a distributed system. In consistent hashing, we assume an imaginary ring, something like this, and we place all our servers across this ring. Let's assume this is server 0, this is server 1, server 2, server 3. Let's assume 4 servers are placed on top of an imaginary ring and the keys are present on this ring as well. Let's assume we have 16 keys are placed like this and 4 servers are placed like this on an imaginary ring. In real world, we perform some well-known hashing function, for example, SHA-256. Using this hashing function, we calculate hash value of every keys. The same hash function will be used to evaluate the hash value of every server. That means the same hash function will be used to calculate the hash of keys as well as server. We will take the hash function intelligently so that all my keys and servers will be uniformly spread across the imaginary ring. That's the target. And the rule is all these keys will be stored within the server S1. All these keys will be stored within the server S2. Similarly, these keys will be in S3 and these keys will be within S0. That means keys are stored within clockwise nearest server. This is the initial setup and rules for consistent hashing. Now let's understand the beauty of this setup. Let's assume S2 server is no more into the system. In other words, S2 server has gone down. Then what will be the redistribution of keys? Will these keys be redistributed to other servers? The answer is no. Will these keys will be redistributed to other servers than S0? The answer is no. Only these 4 keys which were there in S2 will now be pointing to S3 because S3 is the clockwise nearest server for these 4 keys. So what is the benefit? Very less redistribution of keys. if we take it mathematically, it will be k by n, where k is the number of keys and n is the number of servers. So in our case, total number of keys were 16, total number of servers were 4. So nearly 4 keys will be redistributed. If we consider this example, only 25% of the keys are getting redistributed when one single server is going down among these 4 servers. For simple hashing, the value was 70%. In case of consistent hashing, the value is 25%. You can see the benefit of using consistent hashing over simple hashing. Why we want to reduce the redistribution of the keys? Because redistribution of the keys is a very expensive operation in software system. Hence, our target will be to reduce the redistribution of keys as much as possible, and consistent hashing over simple hashing is helping us to solve the exact same problem. Considering the benefit of consistent hashing, lot of real-time systems uses consistent hashing over simple hashing technique. DynamoDB, Cassandra, Akamai, CDNs are prominent example of consistent hashing using consistent hashing. Now in distributed system, no systems are flawless. Consistent hashing also has some problems. Let's understand them one after other. It has non-uniformity in server load. Initially, during the setup, we identify the hash function intelligently so that all the keys and the servers are well distributed in the ring. However, as and when time passes and new servers are getting added or existing servers are getting down, in such cases, few servers will have more loads than others. For example, if you see here, S0 is storing 4 keys, S1 is also storing 4 keys, whereas for S3, all the 8 keys are now getting stored in S3 because S2 is down and the nearest clockwise server is S3. So even though we started our system with uniform distribution, over the period of time, few servers can be loaded heavily than others. And if any server is loaded heavily, there will be high chance of server crash. Apart from this, in real world, we want more keys to be stored in the server which has high resources than the others. But if you see the initial setup, we are identifying a specific hash function which can well distribute all the servers and the keys. And next time when one server is going down, it can happen that the server which is getting double load has very less resources compared to other servers which has very less number of keys, though they have higher resources than the overloaded server. In order to solve all these issues in consistent hashing, we have a solution known as virtual node. Let's assume we have similar setup of 4 servers. We have identified a specific hashing method which distributes all 4 servers on this imaginary ring. Now we will also introduce virtual nodes. Let's assume this is a virtual node of server 3, VS3. There is another virtual node for S0, virtual node for S1, virtual node of S3 assume. So we are assuming we have 4 physical servers and we have 4 virtual nodes. These virtual nodes are the virtual positions of existing physical server. Let's see how these virtual nodes are helping us for better distribution of the load. Assume we have a key here, another key here. This is also the key distribution. Let me add some more keys so that we can understand the system clearly. We can have a number of keys here. It can be 16 or more than 16 as well. However, for simplicity, for cleaner picture, I have added fewer keys so that we can understand how these virtual nodes are helping us for better server load. In this situation, where this key will be stored, it will be stored within S1 because S1 is the clockwise nearest server. What about this key? This key will not go to S2. This is not the case now. After introduction of the virtual server, this will not be stored within S2. This will be stored within the virtual server of S3. What it means? This means this particular key will be stored within S3 physical server. As simple as that. This key will be stored within S2. This key will be stored within S0. This key will be stored within S3. This key will be stored within S1. This key will be stored within S0. Now, if server 2 is going down, what will happen? Only this key, only the key which was pointing to S2 needs to be redistributed from this place to virtual server S0. So now if you see, even if S2 is going down, all the loads will not go to S3 because we have a number of virtual servers in between. In that way, the keys will be well distributed even after one server is going down. Hope you have realized the benefit of introducing virtual node. Virtual nodes are the imaginary servers which are present physically in some different location in this ring. Even though this particular key should be stored within S2 in order to keep the server load uniform, we have introduced virtual S3 node here so that this key will not be stored within S2, rather this key will be stored within S3. In this way, virtual node works in consistent hashing. This setup solves the very first issue what we had in consistent hashing. Let's understand how we can use the same virtual node concept in order to handle heterogeneous servers. The similar setup we are making S2 and S3. These were the physical server. I have placed them on an imaginary ring. Now let's assume S3 has highest number of resources and then S1 and then S0 and then S2. S3 has highest resources and capabilities as a server and S2 has lowest resources we have in the system. In order to handle these heterogeneous servers in a single consistent hashing ring, we can plan to have more number of virtual nodes for S3. Let's say it is 3. For S1, it is 2. For S0, it is 1 virtual node. For S2, there is no virtual node we will be adding in this ring. VS31, VS32, VS33. These are the 3 virtual nodes representing the same server, the same physical server S3. Let's say for S1, we have 1 virtual node here, VS11, and 1 virtual node here, VS12. For S0, we have a virtual server here. And for S2, as it has very less resources, we are intentionally keeping no virtual nodes for S2. Now, hope you can understand how intelligent this system design is. If we add a number of keys here, what will happen? Most of the keys will be stored within server 3, then within server 1, and then within server 0, and finally very few keys will be pointing to server 2. So only the keys which are present here will be stored within S2. However, for S3, if you see all the keys which are present here, all the keys which are present here, and all the keys which are present here, all the keys which are present even here will be stored within S3. So in S3, a large number of keys will be stored. However, for S2, very less number of keys will be stored. In that way, the feature of virtual node in consistent hashing is also solving our second issue which was there in consistent hashing. Hope you have realized how simple and intelligent consistent hashing system is. Let's summarize what we have learned in this session. We started with the simple hashing technique. Remember, the hashing technique in distributed system design is the key. Any kind of distribution, it can be number of requests distribution or data distribution among a number of servers, you need hashing. In simple hashing technique, we use a hash function to calculate hash of a specific key, and based on that hash function and the number of servers we have, we identify or evaluate the server ID where the key will be stored. We used a very simple function and identified that distributing the keys uniformly among a number of servers are very easy in simple hashing. However, if one of the servers goes down, we need to perform redistribution of the keys. We realized for simple hashing technique, the major problem is large number of redistribution of keys. We took an example and realized more or less 70% of the keys needed to redistribute in our example. In order to solve that issue, because redistribution of keys are the expensive operation in a distributed system. In order to reduce it, consistent hashing came into picture. Consistent hashing reduces the redistribution of keys by a large factor. Remember, for consistent hashing, same hash function is used for both keys and server placement in a virtual ring. A large number of real-time systems uses consistent hashing today. DynamoDB, Cassandra, Akamai, CDN, all these large systems use consistent hashing. However, all the components of a distributed system has some flaws. Even consistent hashing faces lot of issues like non-uniform server load and difficulties while handling heterogeneous servers. We realized there is a well-known solution called virtual node. This virtual node concept solves both the problems of consistent hashing. Hope you have enjoyed this session. If you have learned anything new, do not forget to like, share and subscribe. Thanks a lot for watching this video.